Okay, we're going to be going over the future value of an annuity. So we have to talk about what an annuity is. An annuity is an account you will have where you make regular payments into the account. So this is different from calculating just compound interest. I want you to think of it. Compound interest would be like, I put $100 in the bank. Oh, that's a bad thing to use. Let's say we put $122 into the bank, and I get so much interest every single month. Okay? And I'm just leaving the original amount I started with. An annuity is where you're going to make regular payments. Okay? And those regular payments are going to occur each month. So let's say you get $122 per month. And then with those $122, you earn interest every month. So your first account, let's say you earned 10% interest on $122. That's about $12.20. But in the second month, you add another $122 on top of the original and the interest. So there's a lot of compounding things going on. Okay? So this is the formula to calculate. This is the A stands for the future value of an annuity. Okay? R is our regular payments. They're going to be our regular payments. So how much I put in every month or year or week, depending on what it is. There is a formula that represents I. I is not just the interest rate. I is the interest rate per compound. Okay? So we talked about if we're getting money every month, usually they give us interest rates per year. So we'll have to take the interest rate, which will be our R, and divide it by the compound period, which will be our C. Our exponent N stands for the number of periods the annuity exists for. So you'll also have to take the compound period and multiply it by the number of years. So this seems like a lot of mixed up information. We're going to try to explain it all with a question here. Go ahead, Paul. So, we have Jason. Sorry, give me a sec. So we have Jason, and he makes $800 a month. Okay? So let's say Jason takes all of his money, and he decides to put it into this account. The account earns 2% a year, so I should put per year here. But it has a compound period of monthly. Okay? So we're going to have to do some calculating with that, figuring out what that means. We want to figure out how much money, if he does this for 5 years straight, how much money will he have in his bank account? Okay? So, we're going to have to define a few things here. First of all, the R, which stands for the interest rate, okay? Our R in this case is 2%. We have to turn this into a decimal. What will 2% be as a decimal? Yes, good. So we need to write it as 0.02. Okay? Our compound period, which is C, what are our compound periods? So because this interest rate is per year, what did they say? They said it was monthly, right? That's right. So that means there's going to be 12 compound periods per year. Okay? So our C in this case is going to be equal to 12. So we have to get used to defining things, whether it's monthly, weekly, bi-weekly, bi-monthly. We have to figure out what all of those things mean. We'll make a list for you after. Okay?
So you guys go by two?
We'll talk about it in a second. His regular payments, which was the capital R, are going to be the $800 he puts in every single month. Okay? So his regular payments will be $800. And we needed to figure out years, if you guys recall. How many years will he be doing this for? 5 years. Okay? So that's very important. So let's get our formula again to calculate the future value. Our future value, which is known as A, the amount, is equal to our regular payments multiplied by 1 plus I. We don't have an I yet, or an N. Subtract 1. Let me just double check. Yes, it is. Subtract 1. Divided by I again. So let's look at the information we've gathered. I don't have an I or an N. Okay, the only thing I do have is the regular payments. We actually have to calculate I and N from this information. If you guys recall, I was equal to the interest rate divided by the compound period. Okay, so this is the amount of interest you earn every single month. We're taking the yearly amount and dividing it 12 times. So the yearly amount was 2%, 0.02, divided by the compound period was 12. So we divided by 12, and we're going to get a value here. We'll take out a calculator. Divide 12. 2 zeros, a 1, then a 6. 0, 0, 1, 6, and we'll round it to 7. So our I value, which we just calculated, is going to be this number here. Okay. So every single month, this person earns a little less, well, actually, 0.1% or 0.16% interest. And we need to calculate the number of periods. So how long is this going to occur for? Well, we know it's going to be over the course of 5 years. So N was equal to the compound periods times year. And there's going to be 12 months in every one of those years. So our N will be 60. So now we can start to replace all of our values. A is equal to our regular payments. It's C times YR, yeah. 1 plus our I, we'll write this in purple. Okay. To the power of N, which we did in blue here, minus 1, all divided by I again. So let's plug in our values. Oh, that went a little far. We said his regular payments every month were going to be $800. The amount of interest he's going to earn every month is decimal 0.00167. The number of periods this occurs for are 60 over the life of this annuity. And we're going to have to divide it again by that interest rate. Oh, I meant to do that in purple. Which is 0.00167. So from this point, it's just simply calculating. So let's simplify using BEDMAS. We have 800 times 1.00167 to the power of 60, which we'll definitely need a calculator for. Then we're going to subtract that value by 1, and the very last thing we're going to do is divide by 0.00167. So I'm going to try to do this all in one, or all together on my calculator. So the very first thing I want to type in is my exponent I have at the very beginning. Oh, that's not the calculator. Okay. So let's type in this exponent we have, 1.00167. And we're going to put it to the power of 60. Okay. Then we're going to subtract from it this value of 1. Okay. Which will then be times or multiplied by 800. And then the very last step will be to divide by this decimal of 0.00167, which equals 1,000. Is that a decimal or what? I'm making an error here? One second. Sorry, when I typed the number in on the calculator, I made an error. But this is the number we should have ended up with. $50,442.92. So, $50,442.92. So, if Jason continues this practice for 5 years, okay, in a very reasonable bank account, earning 2% every single month, and he invests $800 every month, he'll end up with $50,000. But let's think about this. Let's actually figure out how much money did Jason actually put in. He put in 800. How many times did he put 800 into the bank? 12 times a year, but how many years did he do it for? 5. So what is that number? which is, just did it a second. What was our N? Our N value was 60. That's how many times he invested the $800. So let's actually figure this out. Okay, 0, 0, 0, 48. So Jason put in $48,000. Okay, and over the course of that year, or 2 years, he earned $50,442.92 minus the $48,000. Jason earned $2,442 in interest. That's a pretty good amount of money he's earned from just putting money into a bank account that gives him